So if we go into section 3.2, 3.2 is on ion formation. Right. So everything that we've talked about up to this point, we have assumed that our number of protons and our number of neutrons, our number of protons and our number of electrons are equal. That gives us an atom with an overall neutral charge. Turns out that's not always the case. So if we have an unequal number of protons and electrons, so protons do not equal electrons, we have an overall net charge on the atom. And we no longer actually call this an atom. We now call this an ion. Right? So if we look at ions, if we have more electrons than we do protons, electrons are negative, protons are positive, more electrons than protons. So electrons are negative, so it stands to reason that this would be a negative ion, right? And we call a negative ion an anion. Okay, anion. If we have more protons than electrons, of course, protons are positive, electrons are negative, so we are going to have an overall positive charge. To give us a positive ion, we call that a cation. All right. Let's go back here and let's look at our friend chlorine from this same example that I gave in section 3.1. Actually, exact same one that I drew in section 3.1. All right. We look at this. We have 7 valence electrons in our outermost shell. And so our easiest route to getting a full octet for chlorine is going to be for it to pick up another valence electron from somewhere. Now, where? That's more section 3.3 topic, but from somewhere, right? Now, chlorine really, really wants to pick up that extra valence electron, which makes chlorine extremely reactive. But we pick up 1 valence electron. That now gives us 8 in our valence shell. Right? So with 8 in our valence shell, then we now have 1 more electron than we do protons. And so this chlorine has a -1 charge. I hope if I spelled chlorine correctly. All right. Now, let's look at a different possible example. Let's say we have a sodium atom. Sodium has 11 protons, so let's look at our n equals 1 shell. We're going to have 2 electrons in it. Our n equals 2 shell, we're going for 8 electrons total. All right, we're going to have 11 electrons total. 1, 2, 3, 4, 5, 6, 7, 8. Then we go out to our n equals 3 shell. We've accounted for 10 electrons. So we're going to have a third one here, right? Now, sodium wants a full octet also. But it turns out it's going to be a lot easier for it to give up 1 electron and just eliminate this n equals 3 shell completely. And so when it does that, of course, when it gives up 1 electron, it's going to form a +1 charge, right? Now, we can sit here and we can sort of rationalize through what's the easiest path to a full octet. Or we can look at trends on the periodic table and figure that out. So let's revisit our periodic table. All right, so group one, we talked about group one having one valence electron. They want to give that up. Group one elements tend to form +1 ions. Okay. Group two elements have two valence electrons. It's a lot easier to give up 2 than it is to get 6 to get our full octet. So group twos are going to form a +2 charge. Group 13, once again, skipping the transition metals for now. Group 13, we have 3 valence electrons. A lot easier to give up 3 than to gain 5. So this is going to form a +3 charge. Now, group 14 gives us a little bit of an interesting scenario. We have 4 valence electrons. And so we could say in a way that it's equally easy to either lose 4 or gain 4. Or also, interestingly enough, this half-full valence shell is actually sort of stable. So group 14 elements tend to not form ions. Right, we go on to group 15, though, have 5 valence electrons. Our easiest route is to gain 3 electrons. So these tend to form a -3 charge. Group 16, we need 2 valence electrons. Gaining 2 is easier than giving up 6. So these tend to form -2. Group 17, -1. Okay? Then, of course, group 18 doesn't really readily react. So that's our trend for forming ions. Right. Now, once we've formed an ion, though, let's talk about how we name it. For a cation, remember a cation is a positive ion. We just take the name of the element and stick ion on the end of it. So sodium with a +1 charge is a sodium ion. Easy enough, right? Magnesium is a magnesium now, for anions, we have a little bit of a different rule. For an anion, we change the ending to IDE. So a chlorine ion, we actually call chloride. An oxygen ion, we call oxide. Now, we have this group of things that you all will need to know called polyatomic ions. Polyatomic ions are groups of elements that are bonded together, but they function together and as an ion. Okay? Now, there are a couple of these that you all need to know. We treat these as one unit. We can't split them apart. We can't do anything with them. If you see, just for example, NO3-, which is nitrate, one of the ones you need to know, it stays as nitrate, NO3 with a -1 charge. Another one, hydroxide, OH-. Sulfate has an is SO4 with a 2- charge. Then phosphate is PO4 3-. By the way, don't confuse sulfate with sulfide. Sulfide is a sulfur ion, which is going to be S2-. Don't confuse phosphate with phosphide. Phosphide is a phosphorus ion. P3-. All right. Then our other one that we need to know is ammonium. This is our only polyatomic cation that we care about, NH4+, right? Know those. Now, our last thing to talk about in this section is going to be our transition metal ions. Right? So our transition metal ions. Okay. Remember I said that we can't really predict these. One of the reasons for that is that they can oftentimes exist in as multiple different ions. Just for example, iron Fe commonly is +2 or +3. How do you know that? Or how do you know which it is? You'd have to be provided that information. But just for naming purposes, we use a Roman numeral to indicate the charge. By the way, metals are always going to be positively charged, at least any metal that we deal with in here. Metals are always going to be positively charged. Metals always form cations. So iron +2, we are going to call iron Roman numeral 2. Iron +3 is iron Roman numeral 3. Works the same way with chromium +6. Chromium 6. All right. So that's our transition metal ions. That sets us up to talk about section 3.3, which is on forming ionic compounds.